The COVID-19 crisis has forced many events to take place behind closed doors. At ONHYS, we wanted to visualize the risks of virus propagation in a large venue such as Wembley Stadium. Using the ONHYS ONE software, we recreated a 3D model and simulated the typical behaviors of spectators around the entrance of the stadium. If the stadium operated at full capacity as usual, our simulation showed that each infected person would transmit the virus to 2 other people, producing an R rate of 2. How can we reduce the R rate? It is clear that the use of face masks has a significant impact in reducing the risk of transmission, but is it enough to keep R rates low? From an initial R rate of 2, when we took into account the use of personal protective equipment in our simulation, we managed to arrive at an R rate of 0.4. However, an R rate of 0.4 represents around 300 infected people. Under these conditions, it would be unreasonable to reopen any stadium. We simulated several other scenarios by varying attendance levels, but our results showed similar R rates. We then modeled different pedestrian paths around the entrance gates of the stadium and simultaneously enforced the use of face coverings. Our simulations showed that with these measures in place, the number of infected individuals remains low, even with high attendance. This scenario presents an R rate of 0.11. This is a 95% decrease from the original R rate of infected individuals. By adding further measures to control pedestrian flow, high attendance could be maintained while simultaneously ensuring the health and safety of spectators at Wembley Stadium. ONHYS ONE informs decision-making. By recreating specific venues and simulating natural pedestrian behavior, ONHYS is able to design scenarios that allow for the simultaneous management of pedestrian density whilst also significantly reducing the risk of virus propagation.